Okay, guys, let's look at lesson 15.
People watching the video later.
Okay, lesson 15. Interval notation, products of linear factors, tangents, increasing and decreasing functions. So a little bit of this, a little bit of that. Definitely a decent amount of review in here. Okay, interval notation. I think you guys are probably pretty okay with interval notation. Remember, we use interval notation at times instead of inequalities. So instead of the less than, greater than symbols, all that. Remember, we use the closed, so the brackets, in place of when there should be a solid dot. So when it's an equal to, we use the open intervals, so the parentheses when it would be an open dot. So when it's not equal to. So let's practice writing these inequalities in interval notation. And I won't, pre-cal we tried to do a lot of interval notation. In calc, I feel like we just kind of use them both randomly. I don't feel like it's always use this or always use that. I feel like we just randomly use them both. So, thoughts on 4 less than x less than or equal to 30?
Parentheses 4, 30 bracket, comma, 30 bracket.
Because where is the shading for an interval that's 4 less than x less than or equal to 30? The shading is in between them, right? And so my interval starts at 4, it's not equal to, so parenthesis, comma, my interval ends at 30, it is equal to, so bracket. Does that sound familiar?
Yep.
Okay. What about x greater than or equal to 22?
Bracket 22,
Okay. If it's x greater than or equal to 22, where does my shading start? It starts at 22. It's equal to, so bracket. Greater than, so where's my shading end? Positive infinity, which always uses parentheses. Okay, what about C? X less than negative 42.
negative.
My shading begins off in negative infinity. Infinities always use parentheses. Where's my shading end? Negative 42 with a parenthesis. If you're ever unsure, do a quick graph. Okay? A quick graph can help you figure that out a little bit. Okay. Good. On which intervals is this function positive? Thoughts on what we mean when we say on which intervals is this function positive?
Where is it above the x-axis?
Good. Okay. When you're asked when or where a function is positive, we're asking the function in general is defined by y. So when are the y values positive? Which, yes, goes back to when is it above the x-axis. So one way you can ask yourself this is, when is y positive? Or, as you said, above the x-axis. So, what do you think here? What's an interval that is positive?
Negative 4 to 4.
Okay. So right here, if we look at this middle hill, from negative 4 to positive 4. Now, it does say positive. Does it say when is it equal to 0? No. So I would probably say parentheses on this one, just because it's not asking when it's equal to 0. It's just asking when it's positive. And technically at negative 4 and at positive 4, it's neither positive nor negative because it is equal to 0. They're spraying the lockers probably. It's the spray gun.
Less than negative 6. Or negative 8.
Yeah.
Okay. So it's in your notes right in front of you.
Yeah, that's good.
Too easy. Okay. So less than negative 8, how do I express that in interval notation?
Negative infinity, negative 8 with parentheses.
Okay, negative infinity to negative 8. And that should make your last one easy enough.
Positive 8 and positive.
Yeah.
8
Oops.
and then drifting.
Mine's really tripped the way I started to get rather squished. Okay. Are we okay with our positive intervals?
Yeah.
Okay. Moving on then. Products of linear factors. Again, this will take us back to some pre-cal.
Yeah.
Okay, so first of all, definition. What do I mean by linear factor? When we talk about linear factor, we're talking usually about like a binomial. Like the example here is x minus 2, x plus 4. Those are linear factors. It's linear because the power is only x to the first. Okay, more than that and it's no longer linear. A product of linear factors is the following. So if you see a product of linear factors, x times x plus 3 times x plus 6 times x minus 2 times x minus 5. Those are all linear factors. Now, the question follows. What are the zeros
0.
of the above product?
0.
0.
Negative 3, negative 6, positive 2.
Okay, so basically when they're asking for zeros, you take each factor and set it equal to 0. You've been doing that since Algebra 1, technically. So my zeros are 0, negative 3, negative 6, 2, and 5. Okay, so we're good there. Now, the important part of talking about that is these are the locations where the graph will change signs. It will change from either positive to negative or negative to positive. Because if we look at the one that we did up above, at negative 4, before negative 4 my graph was negative, after negative 4 my graph was positive. So these are the places that my sign will change. And that is important to understand, especially, I don't think we actually do the graphing today. No. We'll definitely do work on doing some rational graphs by hand. And that's one of the big things, being able to identify your zeros and stuff will help you graph it. Okay, so this example asks us to use a number line and interval notation to show the intervals on which this function is positive and the intervals in which the function is negative. So, it says use a number line. So guess what I need to draw?
A number line.
Big old number line. And, yes, I am making it a long number line because I want room to work, room to space my stuff out. What numbers are going to need to go on this number line if we're checking about whether where the function's positive and where it's negative? All the zeros. So, that's going to include, let's see, what's my smallest? Negative 6. Now, keep in mind, I'm not going to put, the way I do this one, I'm not going to put my other numbers on here. Okay? Not that you couldn't, but I'm just going to put our key numbers because I don't really care how it's spaced, honestly. Smallest is negative 6. The next smallest is negative 3. Then we have a 0, 2, and 5. Correct? Again, the way I do this, the way I see most books do it, I don't care about spacing. Okay? Now, how do we decide? Do you remember how to do this? How do we decide what's going on over here left of negative 6?
Plug in a number from left to
Okay, plug in a number. What number represents this interval? Negative 7. Now, Mallory picked negative 7. We could pick negative 8. We could pick negative 9, negative 10, negative 11. It doesn't matter, right? And I don't care what number mathematically. We don't need to grab a calculator here. But, okay, -7. When you put it in for x, it's going to be a negative factor, correct? What about -7 plus 3? That's going to be negative. -7 plus 6? Negative. -7 minus 2? Negative. -7 minus 5? Negative.
When you have an odd number of negatives, it'll be negative.
5 negatives, odd number of negatives multiplies to be a negative. So this interval is going to be negative.
I remember doing this.
And I say, I'm hoping it's coming back to you because you have done this. Really, did we do this back in Algebra 2 or only maybe only pre-cal?
I remember this though,
It was
actually.
really early in pre-cal.
Yeah.
Yes, it would have been first semester pre-cal as opposed to trig.
Yeah.
So,
No, I
okay,
remember this.
so what do you do between -6 and -3?
Find a number.
Pick a number you want to test. So,
I'm guessing it's all going to be negative. No, come on.
-4, when you plug it in for x, is negative. -4 plus 3? Negative. -4 plus 6? Positive. -4 minus 2? And -4 minus 5? Negative. This time I have 4 negatives and a positive, which multiply those all together turns out to be a positive. Okay. What about between -3 and 0? -1. So -1 is obviously negative. -1 plus 3? -1 plus 6? -1 minus 2? And -1 minus 5. 3 negatives and a positive is a negative. Between 0 and 2? 1. Oh, hey, 1 actually starts off as positive. 1 plus 3? 1 plus 6? 1 minus 2? Whoops. And 1 minus 5. Did I do that right? Yeah.
Yep.
3 positives and 2 negatives multiply together to be a positive. Okay, between 2 and 5. And I'm just writing the numbers I'm picking up there just for reference sake. You don't have to write those out. I picked 3. I don't even think you guys said it. I think I just did it. Positive. Oh, did you? Okay. 2 plus 3. Or excuse me. 3 plus 3. 3 plus 6. 3 minus 2. 3 minus 5. So 4 positives and a negative, if I did that correctly, which is a negative. You can take a guess on the next one.
Negative.
No.
Mr. Difficult back there.
6.
Okay, if we pick 6, positive, 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 positive. I guess I should have said take an educated guess. Silly me.
Silly good.
Now, as long as, okay, so what you need to realize here, as long as these are just linear factors, we don't throw any quadratics, any squares, anything fancy on. That'll come later. But as long as these are just linear factors, realize my sign is going to change at every 0. Okay? So, to an extent, if you know what you're doing, once you get the first sign, you can go from there. I say to an extent because you do have to be careful. So, first of all, it asks me to write the positive intervals and negative intervals using, did it say interval notation? Yes. So, what are my positive intervals? But what are the intervals? -4 is in between which numbers? No. Forget the numbers we tested with.
6 and 3. -6 and 3.
You see where I'm going with that?
Yeah.
Use the actual zeros. So from -6 to -3 is a positive interval. What's another positive interval? 0 to 2 and 5 to infinity. Okay.
Looking at the wrong number.
So maybe for that sake, that makes me think I shouldn't write my testing numbers up there.
Yeah. Well, no, I'm just.
You're just having a moment.
Mallory's having a bad day.
My brain's everywhere.
Okay, so what are my negative intervals?
The other ones.
The other ones. Negative infinity to what number? Negative 6. Okay. And negative 3 to 0. 2 to 5. Okay. So I do have kind of a side note written here in my notes, which is basically what I talked about, that the sign changes every time. For products of non-repeating linear factors, the sign changes at every 0. So I'm going to write it in here so it's written in words. For products of non-repeating linear factors, the sign, S-I-G-N, changes at every 0. Okay. What's a tangent?
A line that touches the circle at 90 degrees from a radius.
Okay.
A line that barely touches a curve in just one place and doesn't intersect the curve.
Okay. If we think about a tangent on a circle, you know, it touches the outside of the circle, but it doesn't cut through it, right?
Yeah.
So it's tangent, you can in a way say intersects in one place. So it talks there about meaning to touch. A tangent line is a line that barely touches a curve, just one place, does not intersect the curve. I don't know. It just touches it. A touch and go, just kind of brushes by it.
Hit and run. That's geometry, right?
Trying to think, did we learn? Probably learned tangents in geometry, unless you learned them before.
We saw them in geometry. Where they was like, there's a circle and it's like this.
Yeah, because you would have had them in
I
various.
a little bit of math with them, which one time.
Yep. Okay. Look at the following diagram, and then the directions aren't written here, but we're going to talk about them. So, at what points do you see tangents? I was just waiting for a glance. Q and P?
That's facts.
Okay. So at Q, this tangent is touching that curve, but not going through it. At P, this line is touching the curve, but not going through it. What about points R and S?
It goes through.
It's an intersection.
Okay, those are actual intersections. So, first thing I'm going to write down here is that they are tangents at Q and P. Now, just vocabulary's sake, we can say that there are points of tangency at what x values? Right. Okay, and that's just some kind of vocabulary here, in that there are points of tangency at x equals 7 and x equals 20. Okay. Now, we're going to talk more about tangencies here tangents on the next one. Key point. The slope of a curve at a point is the slope of the line tangent to the curve at that point. Okay. When we talk slope, you guys are used to talking about the slope of a line, right? Mm-hmm. And the slope of a line, it's a straight line. So that slope is the same all the way around. If we look at whether it be this curve up here, this curve here, is the tangent the same at every place? No. I mean, here we've got a positive slope, here we've got a negative slope. So you can't talk about the slope of a curve in general because it's a curve. It's a changing slope. But what we can do is we can talk about points and what their slope is. So, the slope of a curve at a point is the slope of the line tangent to the curve at that point. With that in mind, this question is asking for what value of x does this curve have a slope of 0? What does a slope of 0 mean to you? Okay, a slope of 0 goes along with a horizontal line. That's old news, right? Going back to our Algebra 1 days. Sorry, taking you back to middle school. Now, with that in mind, do you see places where this curve has a slope of 0? On top of the curve? It's like the one they have drawn in for you there. Right there. That's a horizontal line, yes? Drawn sitting on top of the curve, on top of that max. And so right there, at x equals 8, that is a value of x where the curve has a slope of 0. So where that maximum point is. Now, if I caught it correctly, Nathan used plural there, I believe. So where else are we talking about? Oh, now he's saying mins and maxes.
With the points.
Okay. I feel like earlier he said at the tops of the curves.
Yeah, I did.
And so that would be at 2 and 16. But I think after I talked a little bit, the connection is being made that it's also going to happen
At the mins.
at the mins. Because you can draw horizontal, yes? Any place you can draw a horizontal tangent line. So also, well, that one didn't even touch, but any of those places. That has a slope of 0. So x equals 8 is the one that has the line, but we also had them at x equals 2, 6, 12, and 16. And the short of it is, any place there's a min or a max, right? Okay. Questions there? Okay. Increasing and decreasing functions. We did increasing and decreasing in pre-cal. I think it's chapter 1 because I think I'm getting ready to teach it here very soon in pre-cal.
Just on the P's.
Nope, we're out of P. We're in 1. We've moved up. We're in an actual chapter. Yep. Chapter P, I mean, Chapter P just had their Chapter P test last Friday. I mean, Chapter P takes a while. Chapter 1 takes even longer, though. Okay, so, increasing functions. If a portion of a function is increasing, it is rising uphill, kind of like a positive slope, right? If it's a decreasing function, it's falling downhill, like a negative slope. If a function is increasing from A to B, then it is increasing over the open interval from A to B. So we can talk about on what intervals a function is increasing or decreasing, if you recall. So this one says, on which intervals does the function graphed here appear to be decreasing? F to what? Okay. Do you guys agree with her? That from F to G? What was it? Okay. Yes, am I off the page? Okay. So I was drawing arrows there to just kind of show the visual decreasing. So from F to G, from D to E, and B to C. In other words, why did we start with F to G?
Yeah, why don't we do it from right?
I said it first. That's probably why.
Because Mallory's the one that volunteered the answer, and Mallory started with F to G. If you look at my notes, guess what?
It's probably the right way.
It's the other way.
The right way to do it.
But
Left to right.
I went with technically doesn't matter. I was trying, there's times that I just refuse and I still do it my way no matter what. But then there's times I try and go with what you guys say. This was one of them.
My brain.
And of course, I went with what Mallory said and Logan complained. So that's fine.
You know what, Logan?
Okay. Example 6. Last example. Use a
Graphing calculator.
graphing calculator. Estimates the intervals over which the function appears to be increasing.
Is this the fastest node out here?
That's one of them. Now, though I will say, this problem's going to take us a moment.
Gosh dang it. Dang flabbit. I think I hear that. Where's Hannah piano?
X plus 3, x plus 6, x minus 2, x minus 5.
Looks like me in art class.
I got to zoom out so much.
Whoa.
So if you watched it graph, you can see it going up, down,
Yeah.
up, down, so on and so forth. As I said, it's going to take us a bit to figure out the increasing, decreasing. You want me to make this more difficult or easy on you?
Easy.
Easy.
Duh.
Ooh, I don't know how. Okay, so let me try something with my windows.
Go to 100.
Okay. So I'm going to make,
Do it to a million.
okay, my Y min and Y max obviously have to change. I'm going to make my Y min negative 570.
Oh my goodness.
I'm going to make my Y max 710. Now, I'm not sure what this graph is going to look like because I'm doing this on the fly.
Mine's the same as yours. Wow.
Look at that. Crazy.
Wow.
Nathan, did you say it went down to 80,000? Yeah, I just did zoom fit.
Oh my gosh.
50,000 to 80,000. So why?
Good God.
And this is where I like the idea and concept of Zoom Fit, and sometimes it works beautifully. But did it really need to go that far out for you?
No, with that, it just looks like a straight line.
See, and that's where I don't understand Zoom Fit. Because sometimes Zoom Fit works beautifully. Well, you just got the Mrs. Sargent fit here. That's what you got.
I just think it's perfectly on the screen.
Okay.
That is gorgeous.
Now, in order to figure out where this is increasing, it's not very helpful.
Yeah, it goes up and then straight across.
Exactly. It's not helpful. And this is where you can try Zoom Fit, but just go back and start over. Now, what do I have to know in order to know when this is increasing? I mean, how do we express our answers? How do we express our answers in the last one? Interval notation, we had to know our x values, right? So if we have to know our x values, what are we going to have to find here?
We already found that.
No, we don't need our zeros
I give up.
because are my zeros where
No.
my increasing and decreasing changes?
Maxes and mins.
Maxes and
I
mins.
hate this problem.
As I said, this problem's good. Darren was all excited. We were almost done with notes. This one takes a moment though. Okay, so,
Calculators.
I can run these out.
okay. I'm going to go.
The grind.
I don't know what Mallory's going to tell me. I'm going to work left to right.
Yeah, facts.
Okay? So that means the first thing I need is a max.
I don't know what Mallory.
You guys could split these up if you want. There's a max, a min, another max, and another min. Make sure you remember how to use your calculator here. That is the one thing I would remind here.
Max.
I'm teaching it in pre-cal right now, so if any of them have come up and said, help, how do we do this? Second calc. Max. Remember to go left. Actually, no, I haven't taught mins and maxes yet. They're still trying to get zeros. Left bound. Right bound. Guess.
Our calculators are supposed to be in radians, right? Because I think we changed it in physics to degrees one time.
You'll have to go back and forth.
Okay, because I think Jackson was having.
For this, it doesn't matter, but generally speaking, calc, pre-calc, you're going to want radians.
Okay.
Well, pre-calc, though, once they do that, we go back and forth a lot.
Yeah.
Well, that's how I teach it, is going back and forth. Calculus, we're usually in radians, though.
Okay.
Okay, so this first max, I'm going to call it -5 because it is almost there, right? And 700. I guess it, yeah, I just have 700 written down. I think I just wrote the basics down.
Yeah.
You guys got these all? Do I need to keep going or? Oh, I'm sorry. Well, in all honesty, do the Y values even matter here?
No.
Are we writing them down?
I mean, I wrote them down, but in all honesty,
Well, we need our X value.
you really only need the X values. So now I'm getting a minimum. Now this one, I guess valid point, they probably really should be just 3 decimal places, but for whatever reason, my notes, I just have them written to like 1 decimal place at most. Because I have -1.7 and, yeah, I really went to whole numbers here. Because then I did -236 is what I've written down. But again, I think I probably did that one because the Y values, do they matter? No. You know what to do, right? Whoops. Yeah, I don't know why. I'm just writing down what I already have at this point. Okay, let me know when you're ready to talk about the increasing intervals.
How come you have a -236 for the second one?
Because it is.
Is it? Okay.
Because
No,
it's
I erased my, yeah.
Because it's down there.
because it's this one right here.
I erased my first answer. And
it took part of-
Mm-hmm.
Okay.
Because I went out to like 3 decimals.
Which is fine. There's nothing wrong with that. I honestly don't know why I only did one. Trying to be quick at some point probably. Okay. So what are my increasing values? Where's my first increasing interval? Okay, so right here, as I trace on the calculator, that's -infinity to what is that X value up there? -5. So -infinity to -5. Okay. Then from -5 to this min, we are decreasing. So now, when are we next increasing? Okay, from this min to the next max, so -1.7 to 1.1. Any more increasings?
From that last min
Okay, yeah. So from 1.1 to min, we're decreasing. But then from the last min over, so that is from 4 to infinity. And we have our own personal Buzz Lightyear.
Man, I'm gonna be graphing something later, and it's gonna be super small. I'm gonna get so confused.
Yeah, I need to do that right now. Yeah, hit that Zoom 6 right quick.
And that's exactly what I'm trying to teach my pre-cal kids is Zoom 6 will always take you back to the standard screen, right?
Yeah.
And I always say, you know, always start with that because who knows what I graphed last. Was I graphing for pre-calc or calc or who knows?
Most of the time I have it normal, but sometimes I'll get and it'll start graphing. It's all weird, and I just stop and then feel Zoom 6.
I had a moment this morning. I learned all on my own. And maybe you guys already learned this. In the past, do you remember I've taken you into second stat plot to turn our stat plots on and off?
Yeah.
Did you realize there's a much easier way?
You just go to the top and the
Or
y equals.
If you go right here into y equals where it says plot 1, plot 2, plot 3, if you just up there and just like toggle it and hit enter, of course, then when they're highlighted, they're on. When they're not highlighted, they're off. Which explains to me how, I always get these pre-cal kids that randomly, some of you guys last year, randomly their stat plots would be on.
Yeah.
And then their graph wouldn't work. And I just made this occurrence today.
You can do the same thing with the y equals. If you go to equal sign, you can turn it on and off. If you have an equation, but you don't want it to show up.
Oh, I think I kind of knew that, but
It's sitting somewhere.
You put gamma
Yeah.
on your calculator.
yeah, so if I do that, now it's not showing.
Yeah.
Nice. So if you don't want to delete it all the way out, that's helpful to know because when I'm trying to go back and forth between calc and pre-calc, I struggle some days, but okay. That is our brief calculator meeting.
Well, I've seen this Addy